I'm Elliot Horowitz. I'm the CTO and co-founder of MongoDB. And with me, I've got Joseph Klufiger from Thermo Fisher. And today we're going to talk a little bit about how Thermo Fisher uses MongoDB and about MongoDB Atlas and about how using MongoDB on AWS can really sort of make things really pretty powerful for everyone trying to use data. So without further ado, I'm going to hand it off to Joseph.
All right, thank you. So Thermo Fisher may be the largest company you've never heard of. We have 50,000 employees across 50 countries and $17 billion in revenue. And we try to be the world leader in serving science. One of the ways we do that is with an instrument called a mass spectrometer. Now, I'm a software engineer, so take this explanation with a grain of salt. The analytical chemist in the audience may cringe, but basically the way a mass spectrometer works is you take a sample, a very small quantity of it, inject it into the front of the instrument, and it will be ionized. And then it's injected into a little metal sphere and spun around very rapidly. And large wavelengths represent larger molecules, and small wavelengths represent small molecules. So with this capability, there's a lot of interesting things that our customers can do. For example, they can detect pesticides and pollutants. Basically, anything that's bad for you, our instruments will detect it. Now, for me, this is personally meaningful. My son was born with a cleft lip and palate, and this is caused sometimes by exposure when the baby is exposed to some type of toxin, when they're just pea size, right? Some lead, mercury, etc. So what motivates me to come to work every day is knowing that I'm helping to make the world a cleaner, healthier, and safer place. Another really interesting application of mass spectrometers is the next Mars rover that is going to Mars in 2020 by the European Space Agency will carry on board a mass spec that specifically is designed to identify organic molecules. It's called the MoMA, the Mars Organic Molecular Analyzer. And this mass spec is based on a Thermo Fisher design, a linear ion trap. So it'll be very interesting to see what goes on with this mission. Of course, any discovery would be very significant. Another applications of our instruments is sporting events. So our instruments will probably process, or probably did process, samples from Michael Phelps and Usain Bolt. Now, the software that is used for this workflow is written by my team in Austin. And so we'll talk a little bit later about how we switched from SQLite to MongoDB and saved a lot of lines of code. This is what beer looks like in a mass spec. There's been a lot of that at AWS, reInvent. Now, each one of these features represents a different set of flavonoids that give a product its unique flavor, taste, and texture. So our customers use our mass specs to do product authenticity studies. Is this a Florida orange, or is this a California orange? My favorite example, in 2009, the Mythbusters used a Thermo Fisher mass spec to test the myth that common soda cans might have rat urine on them. So the way they tested this in typical Mythbusters fashion, they took a set of soda cans, 1,000 soda cans, cleaned them, and then let some rats run around on these cans and do their business. They took another set of soda cans, didn't do anything to that set of soda cans, and first used a black light. A black light will fluoresce organic molecules. And they got positive results in both cases. So Adam was a little bit disconcerted about this. And luckily, they had access to the Stanford mass spec laboratory. They were able to run it through a mass spec, and in that case, it came back negative. There was no rat proteins found on the comparison set. So you can drink your sodas with confidence. Here you can see Jamie Heineman showing our Excalibur software, which I will demo in just a minute. And he says, quote, "These mass spectrometers are extremely accurate. They can detect down to a femtomole. And if it says that there's no rat proteins in there, it's not in there." So let me keep it interesting and do a demo in just a minute. I'm going to show, I'm going to remote desktop into a live mass spec. Unfortunately, I couldn't bring it up on stage with me. They're pretty big and heavy. And that's going to be connected to Thermo Fisher Cloud. And then we're going to open up a browser where anyone in the world can see the status of that instrument and the data coming off the instrument. And in the back end, we have a MongoDB that is marshaling that data back and forth. This is a picture of that mass spec. It has a robotic arm on the top. I've got some steroid samples set up, so it'll lift out of the tray a sample, inject it into the instrument for detection.
Right, and at the end of the demo, I'll show a little bit how MongoDB Atlas and how quickly you can spin up a new cluster in Atlas on AWS. So here we go.
Great, thank you. Okay, so here we have Excalibur. You can recognize this from the screenshot with Jamie Heineman. I've got 9 samples set up here. Go ahead and kick that off, and we can see data start to come out of the instrument. See that acquisition queue show up, and then switch to the real-time chromatogram view where we can see that data start to stream out. And then I switch over to my browser, and I can see that same data come off the instrument. So now no longer does the scientist have to sit at the instrument and monitor. They can go to lunch, and from their web browser, or there's also a mobile device, they can keep track of that instrument. Keeping these instruments up and running is quite important. These instruments are probably more expensive than your house, and so any downtime is detrimental to their business. So they can see the samples coming off, they can see the chromatography, make sure that looks good. They can get an event history, any errors that have happened on the instruments, and they can query across instruments in their lab. They can get utilization statistics. Again, they can see how many samples each instrument's running and how much downtime each instrument has. And then they can get notified. Now, let me just back up and give a little bit more information about Thermo Fisher Cloud. Thermo Fisher Cloud is a new offering from Thermo Fisher built on top of AWS. And you name an AWS service, it's probably using it, including Mongo. I'm only going to demo 2 of these applications today, but there are 35 applications total. There's about 150 developers working on Thermo Fisher Cloud. There's 10,000 unique customers. It's probably the largest scientific cloud available today, with 1.3 customer experiments being stored, and another 200 projects planned for next year alone. So Thermo Fisher Cloud is transforming the way our customers work. Today, and this goes back to the first day that the mass spec was first invented in 1899, when J.J. Thomson discovered isotopes, right? Each step from question to answer was a manual step. And even today, our customers will walk from the mass spec, kick off acquisition, get the results, and then process them, do their reporting, and if they want to collaborate those results with other customers or other collaborators, they have to export to Excel, to PDF, and it's a very manual process. With Thermo Fisher Cloud, that story gets a lot better, and we're able to automate those workflows from end to end. From a development perspective, Thermo Fisher Cloud has also affected how we work. Before, developer teams from 5 to 30 developers would create their application, and each team would have a separate set of logging, database access, a different user experience. Now with Thermo Fisher Cloud, we're able to, in a microservices environment, share a lot more code, create a consistent user experience, and spend more time creating customer value and less time creating undifferentiated infrastructure. So let me switch over to Mongo Atlas, and Elliot's going to give you more information about this, the features of this wonderful service. But I'm just going to show you briefly how easy it is to create a new cluster. So all you have to do is choose a name for your cluster, choose the version of MongoDB and the region in AWS, the size of the instance that you need, and the amount of storage. Get a nice little simple monthly estimate of how much it's going to cost, and hit confirm and deploy. And you're off to the races, and just like that, a new cluster is created. So I think that's worth a round of applause for MongoDB. Very well done. So let me demo one more application. This is the sample profile application. And this would have been great for the Mythbusters to use, because it allows you to compare 2 sets of samples. For example, in my mind, I'm wondering, so the second comparison set of soda cans that had fluorescent something on it what was that, right? I would love to run that data set through this application to answer that question. Here you can see the beer data set that I showed earlier. This is what plasma looks like. We've got soy sauce and some water samples. So I'm going to drill down into the water samples. And here you can see some summary statistics about this profile. And then I'm going to drill down into a comparison. So this is a customer in Europe who takes a sample of water from a river in Europe each day. And any differences will show up. Any differences that are statistically significant will bubble up to the top and be listed here. So our customers can see any new emergent contaminants quickly. You can see that there's a difference between the control set in black and the comparison set in red. And if I filter down to a particular compound, MDMA, I have an interesting result here. This drug does not show up November through December 31st, but 2 days after New Year's, there's a spike. So it looks like there was some festivities going on in Europe at that time. Great. The last thing I will show is the dashboard. So you can see all the instruments in your lab. So for the first time, our customers are able to keep an eye on all their instruments at once. Great. So why does Thermo Fisher use MongoDB? MongoDB has become pretty popular within Thermo Fisher. There's 8 applications that I know of. The bottom left one is thermofisher.com. So all product purchases through thermofisher.com go through MongoDB. And with the success of that project, it's split into an additional 2 projects. The top left is the one that I demonstrated, and the other 4 applications are various scientific workflows that are leveraging MongoDB. These are the databases that they migrated from. So scientific apps produce a large variety of data. The way that our customers want to look at that data, the types of data, the rate at which that data changes is quite rapid. So we need a database that can handle that. Also, we produce a lot of large data, right? We talked about how accurate these mass specs are, that they can measure down to the weight of a single electron, which is 0.005 AMU. That, in combination with the fact that these molecules are large and variable, produces a lot of data. Each experiment that I just demonstrated has millions of rows associated with it in our database. If you take a microscope and zoom down into you, this is what you look like. This is a protein, a typical protein. So Mongo is very performant. We've done lots of tests over the past couple of years. I'll share some of those numbers. We get a great developer productivity. We found it to be cost effective. We can use the community edition locally, which does not cost anything. And when we need to scale up, we can use the Atlas, which we talked about. It also runs anywhere. It has a rich feature set and also achieved legal and regulatory approval. MongoDB also is nice because it's so flexible in the types of data that it can contain. It's most well known for its document data capacity, but it also has capacity to store relational data with the new join operator as of version 3.2. You can also use MongoDB for queues with the find and update query. You can use MongoDB to store files, and you can store things like device state very effectively. So you might not use MongoDB in all these cases, but it's nice to have that when you need it. This is an example of a join query. In the top, I have a SQL query joining together 2 parent and child tables, and then the equivalent MongoDB C# driver, which is able to leverage the link features of C# and has a very nice readable syntax for doing joins within Mongo. And you can join any number of tables or collections in Mongo. So the University of Bolzano in Italy did a study, and they found that MongoDB has achieved a critical mass of functionality, such that in the category of match, unwind, project, and group, it is already at least as expressive as a full relational database and also supports joins. MongoDB is about 10 years old now, and I think it's reached a critical mass of functionality so that it can compete with the more established 40-year-old relational databases. This is the evolution of MongoDB. You can see that each version brings a plethora of features. Some of my favorite, the Wired Tiger storage engine in version 3.0, which reduced the disk size by a factor of 10 in some cases. The document DB, or the document validation feature, so you can validate your schemas. The lookup operator for accomplishing joins, encryption, the BI connector for executing SQL queries and translating those into MongoDB queries behind the scenes. The new, in 3.4, views, the decimal data type, collations, the Spark connector, the aggregation framework is very powerful, and LDOP authorization, just to name a few. So we took some measurements. We did the same scientific rigor that our customers use, we used, to compare the performance of MySQL. This is actually Aurora running on AWS with Atlas. This is the schema of the application that we tested. This is the second application, the sample profiler application. And when we convert it to MongoDB, the basic structure remains the same, but some of those children tables roll up into the parent table. So your schema becomes much simplified. On the right, we have the results tables, which will have millions to hundreds of millions of records. And on the left, we have the experiment definitions, which will have 1,000 to 10,000 records. So if I were to reduce my slides down to 1, this would be that slide. This is absolutely phenomenal. What we did is we inserted data into MongoDB and Aurora, and with only 1 line of code, we were able to beat the performance of MySQL. At first, we didn't optimize our MySQL. We basically had a parent-child table that we inserted 1 record at a time, got back the newly assigned primary key, used that, assigned that to the child record, and that was very slow. It took 147,000 milliseconds. Next, we basically built up bulk insert operators. So we're inserting into the parent table, getting back all those primary keys, assigning those to the children objects, inserting into the child table. Drastically improved our performance. Our product manager was very happy about this, 360 times faster. But the fact that it took us 2 weeks and 2 developers, he was not so happy about that. This is what it looks like. This is our MySQL optimized code in 40 lines. And this is the beautiful 1 line of MongoDB, which is still 6 times faster. Now, then we selected the data using MongoDB and MySQL. In this case, we used 600,000 rows of sample compound results. In this case, it wasn't the way we were querying the database. It was the way we were matching up the parent and the child records using 2 nested loops. When we switched that to a dictionary, it sped it up by a factor of 300. But again, it took 29 lines of code, 2 developer weeks. And in this case, MongoDB was slightly slower, but the fact that it only took 7 lines of code, I would still call this a win for MongoDB. And I was talking to MongoDB, and they said probably with the new VPC peering feature, if I were to turn this on, that query would get a little bit faster because it takes a little bit more direct route without VPC routing turned on. This is an update statement in both MySQL and MongoDB. Here, there's really no difference in the performance or productivity. There are similar lines of code. But what I would point out is it's strongly typed in MongoDB. Still, after all these years, the #1 exploited security hole is SQL injection, which in a multi-tenant database is a big deal. So having strongly typed queries that are very elegant, able to take advantage of the language features like IntelliSense and refactoring is really fantastic. This is quite elegant. This was the application that's used in the performance-enhancing drugs testing, and we rewrote the data layer from SQLite to MongoDB, and it saved us, reduced the code by a factor of about 3.5. So here's some comparisons with MongoDB. These are both great databases and both very heavily used by Thermo Fisher Cloud. I think which database is right for you it depends. MongoDB will run anywhere. Dynamo is AWS only. MongoDB has a rich ad hoc query language plus IDE. So for example, when I want to answer the question, which instrument had errors within the last 24 hours, and I want that grouped by instrument type. For DynamoDB, I have to write code, and for MongoDB, I can just write a query. And I also, while preparing for this presentation, several times I exported some records from my database into a JSON object, sent that to my account manager, and he helped me optimize my queries, right? That would be a little bit harder with DynamoDB. MongoDB also supports joins and has a nice aggregation framework. Both databases have excellent performance, and both are easy to deploy. With Atlas, I think the deployment of Mongo is much easier than it used to be. And the only difference is when you want to add additional tables, with DynamoDB, you have to create additional configuration scripts. With MongoDB, I think that's one of the favorite things that people notice when they first started using MongoDB, is there's no create collection statement. You just start writing data to a collection, and if it doesn't exist, it'll create it. Now, as far as native integration with other services, DynamoDB definitely has some advantages here, like integration with IAM roles, Lambda triggers. When you insert into Dynamo, you can execute Lambda statements, Kinesis streams, etc. MongoDB was released in 2009, and DynamoDB was released in 2012. So these are both still relatively new databases, which I expect to continue to grow at a rapid pace. Now, it might seem odd to compare MongoDB with S3, but in a serverless architecture, this is becoming increasingly common. Just raw access speeds, it's about 3 to 7 times faster to access a document from MongoDB compared with S3. In this case, the real-time chromatogram that I showed earlier, where the instrument is streaming up 3 seconds of data at a time, we were able to take advantage of a feature in Mongo, the push operator, where you can push an array of points onto an existing document. And this dramatically improved our performance and took a lot of load off our application server. So instead of sending, at first we were using S3, and that took 2.1 megabytes. We were able to reduce that to 400 bytes. And the same thing is true on the client. You may have 5 clients all requesting data, and they might be at different points. And so they can get just that slice of data from the application server, and then we take advantage of that MongoDB query. And again, here, the MongoDB query syntax in C# is very elegant. We're able to use strongly typed queries. You can see we have a nice filter there that's filtering that sub-document array of points only to the latest data that the client hasn't seen. So when reducing the processing times from days to minutes, there's 2 parts of that. One is the database, the other type is the application, and making our algorithms more parallelized. I'm not going to dig too deep into that, maybe another talk, but we're able to leverage these technologies, AWS Lambda, Docker, and Spark, to improve our processing time. This is a prototype that one of our teams did out of Tijuana, San Jose, and Bangalore to break our raw files that come off our instruments into pieces and then use Lambdas to process those in parallel, do the peak detection, the component detection, the other algorithms that we need to run. And they were able to get much improved results. So to summarize, before I pass it back over to Elliot, Atlas is easy. It's performant. It is seamless to migrate data to Atlas. It's been robust. We haven't detected any downtime since migrating to it. It came out in June. We jumped on it in July and went to production in September. We haven't had any downtime. Even when you scale your cluster, there's no downtime, maybe a couple seconds as it switches the primary. But before I worked for Thermo Fisher, I worked for Microsoft as a consultant. And companies would hire me to come out and apply service packs and upgrades to their databases, their SharePoint servers, et cetera. That was usually a stressful weekend. And at the end of it, I would ask myself, so what additional value have I provided to the customer? And the answer was usually not that much, right? So anytime I can use a service like MongoDB Atlas, I'm going to take that so that we at Thermo Fisher can focus on what we're good at, which is being the leader in serving science. Thank you.
So thanks, Joseph, for giving probably the much better MongoDB pitch than I've ever given. So, like Joseph just ended on, I think with MongoDB, we really focus on making it easy for developers to focus on building their applications. Right? When we started MongoDB, it was very much in line of we want developers to be able to build applications, use data, store data, query data, aggregate data, scale up, do things around the globe without having to think about all the data problems. In all my experience before MongoDB, every time we did anything interesting with data, we ended up having to work around database problems, either build custom databases, do crazy hacks with MySQL, so all sorts of things. And we really wanted to build a database, frankly, pretty selfishly for us, so that next time we wanted to do something interesting with data, we wouldn't have to start from scratch. So MongoDB really was built around, we wanted a database that we wanted to use to make our lives easier so that we can actually build really interesting applications. And that's sort of what we care about the most. So with MongoDB Atlas, it's really the next step in that. So MongoDB is great for developers, but we can make it even easier. We want to make it even easier to get a cluster up and running, to manage a cluster, to run a cluster, to scale a cluster, to monitor, all the things you need to do with your database. We want to make that completely seamless from a DevOps standpoint. So if you think about all the things that go into running a cluster, all the things that Joseph was doing on the weekend when he was sort of doing this with SQL Server, right? It's just a huge number of things. And none of these are terribly fun. None of these are that exciting. But you have to do every one of them. And if you make a mistake, things go horribly wrong. So the question is, can you completely automate all of this stuff away so that you can actually focus on what you actually care about, which is sort of building your application? So what makes a really good database as a service? Well, one, it's got to be automated, right? So nothing you should have to do is manual. It should just take care of itself, both from your standpoint and from our standpoint, right? It's not very good if we build a service and every time something goes wrong, you've got to actually call us or someone gets woken up at 3 in the morning. It's got to be fully automated so things can happen automatically at any point in day in real time. It's got to be fully available all the time, on demand, elastic, so you can scale up, scale down, have stuff immediately. It's got to be very secure, and we'll talk more about that a little bit later. It's got to be highly available, right? One of the key things about any service is that if it takes more work to manage the service than it takes to actually manage the database, you really haven't done anything useful. You've actually just made things harder, right? Anytime you add an abstraction layer and add more work, you've actually just made things much worse for everyone. So you've got to completely cover everything so that you really cannot worry about things anymore. And things like monitoring and backups have to be fully automated. So all the things you care about for your database are done. You don't have to sort of go, yes, I've got a service for running it or maybe upgrading it, but I've got to do backups myself. It needs to be all contained so you can really just say, yes, my database is taken care of. And that's pretty important. So we start out with what it takes to start up a cluster and get it running. And this is what Joseph was walking through. So what do you have to choose to make a cluster? Well, one, you've got to give it a name. You've got to choose an instance size, so basically how much RAM, how much CPU and RAM you want. You have to say how many nodes you want, usually 3. This usually is a non-issue. Whether you want sharding or not. So setting up sharding in MongoDB can take a little while if you've never done it before. With MongoDB Atlas, it is a single click. You say, yes, I want sharding, and you say how many shards you want, and then you're done. Disk space, pretty self-explanatory, and how much disk speed you want, how many IOPS you want from AWS. So now all these things you can set up. You can go through, click the button, get a cluster. But the really important part is that let's say you make a mistake. Let's say you want to get more CPU or more space, or you want to turn on sharding 3 months later. Anything you set when you start up, you can change whenever you want. And whenever you make that change, all those changes are made without any downtime. So if you want to go from one cluster size to another, that's done in a rolling fashion. If you turn sharding on, that's done in a rolling fashion. Any one of these changes is completely done with no downtime to the application, and you really shouldn't be able to detect any changes. So that's sort of the key. So as you scale up, as you resize, if you need to scale down because you over-provision, very easy to manage. It's the exact same UI to modify the data, to modify the cluster as it is to start the cluster up. So there's no sort of new UI, more complicated UI. It literally is just one UI for creating or modifying your cluster. So I think one of the most important things about using a database as a service is around security. There you go. So database as a service, your data is now hosted by us. Is it secure? Can someone hack into it? Maybe you want to store some pretty private information. You want to make sure that's really, really safe. So we've got a lot of security features. The first one, and pretty interesting for AWS, is VPC peering. We'll talk more about that in a little bit. So by default, every MongoDB Atlas cluster is firewalled. So you actually have to put in an IP whitelist to actually have any access to it at all. Authentication's on by default. You've got a very limited set of options you can use to actually open up access to it, so you can keep it very secure and make sure that's safe. And everything is over SSL with sort of real certificates, so you can actually check for that everything's encrypted. No possible man-in-the-middle attacks, so that's all pretty clean, and you just don't have to worry about that. So another interesting part about MongoDB Atlas is that it's a pretty new service. So we launched it in June, and a new sort of database as a service in some ways seems kind of a scary thing. It's okay, well, it's a whole new offering. Is it going to be reliable? Yes, I'm using MongoDB, but what about sort of all the other stuff? Well, the really interesting thing about the way we built MongoDB Atlas is that we've actually been building it for a very long time, but without actually putting this sort of database as a service veneer in front of it. So back in 2011, we launched monitoring as a service. Right? It's called MMS, Mongo Monitoring Service, and it was a service for monitoring your MongoDB instance no matter where it was. So we've had the monitoring service for 5 years now, and the monitoring service has been part of our enterprise package that most of our biggest customers are using on-premise for, I think, 3 or 4 years as well. So the next piece that we launched is the backup service. So we launched the backup service in April of 2013. So it's been about 3.5 years. And the backup components in Atlas are the exact same backup components that are, again, been using in our service for 3.5 years. That is an ops manager, so that every one of our enterprises that's backing up MongoDB, which is basically all of them, are using the same backup components. And last but certainly not least is the automation system. Right? The automation system is the thing that does upgrades, that turns on authentication when you want it, that goes from sharding to not sharded to sharded, changes the number of shards. So that has been out for about 2.5 years now. That came out in October of 2014. So all of the components that actually make up Atlas, that do all the sort of the key bits of it, are actually pretty old and pretty stable. And they are actually the bits running all of our sort of biggest MongoDB clusters in the world, both in the cloud and on-prem. So Atlas really is sort of a database as a service layer on top of all these core components that we've been developing for years. So while it's a new service, it's actually incredibly reliable sort of from day one, because the AWS sort of layer on top of it is actually pretty thin. And we'll talk about that in a second. So we actually feel very comfortable with people like Thermo Fisher, which is a big enterprise, sort of going on Atlas today. So how does this work with AWS? Well, a couple of key things. So one, we have a number of AWS accounts. So I think we started with 10 different AWS accounts, and we put different customers spread across those accounts just for sort of some sanity on our side. Every Atlas customer gets their own AWS VPC. So from a firewall standpoint, from a security standpoint, you're completely isolated from every other Atlas customer. Now, the VPC is running in our account, but it's just for you. So every Atlas cluster is created with at least 3 nodes, and every one of those nodes is automatically put in a different availability zone. So we actually only currently support AWS regions with at least 3 availability zones, so we can guarantee that you're in at least 3 availability zones automatically. You just don't have to think about it. So this is a very basic 3-node replica set. You can see 3 different MongoDBs, each one in a different subnet, in a different availability zone in your VPC. Now the VPC part is relatively important, because as we said before, so you've got your firewall. So the firewall for your project is just an Amazon security group. So we didn't even have to build sort of the firewall rules. So when you go to Atlas and change your IP whitelist, we are just modifying the security group in AWS. So that keeps that very secure, and it's not sort of a new complex component we have to build, all built on top of pieces that already exist that you can trust. So next, as you scale up and you want to go to a sharded cluster, exact same kind of system, except we take care of all sort of the complex things. So in this case, it's a 3-shard cluster. Each shard has 3 nodes in it. You can see that for each shard, there is a node in each availability zone, so it's very highly available. We automatically create 3 config servers for you. You don't have to think about it. We put each one in a different availability zone, so again, very easy for you to manage. And we will automatically spin up 6 Mongo S's for you on different various data nodes, again, so you don't have to think about it. So from a data standpoint, from a Mongo S standpoint, from a config server standpoint, all incredibly highly available automatically. So let's keep going on security. So everyone gets their own VPC. there are three kinds of security rules that we create automatically for you. So one is between cluster members inside between your MongoDB nodes in your cluster. So that's going over the VPC, so that's sort of automatically safe and secure. Then you've got sort of your application and MongoDB, and that's going through sort of your IP whitelist that you control completely. And then we've got one box that we keep on the side so that we can SSH in to help debug problems. And that's it. So I think VPC peering is one of the coolest features in Atlas, especially today. It's a new feature, came out about 3 weeks ago. So the way VPC peering works is you have your VPC, right? This is your existing VPC in AWS. You've got whatever you have in there, whether it's EC2 instances or Lambda functions running. Your VPC is exactly how it is now. And today, let's imagine you've got a sitter block that's like, a /16 and 10.0. Now you're going to create an Atlas VPC, and we do this for you. You don't have to think about it. And you can imagine it's sort of 172.31. So we've got that for you. When you turn on VPC peering, what happens is you go to the Atlas UI. You say, I want to create a peer with my own VPC. You put in your Amazon account ID, the VPC ID, the sitter blocks, and then we make a request into your AWS account saying, we would like to peer with you. You then go into your AWS account and say yes. That peers back with us. Now, it's really nice, because now the traffic from your application to Atlas is over the private network, so it's a lot cheaper, it's more secure. From an IP whitelist or firewalling rule, you can actually just go to your security group and say, I want to add this entire security group as allowed to access my database, so it's much easier to manage. So it's easier to manage, more secure, safer, and pretty easy to do, especially with things like Lambda, where there's a lot of different IP addresses being created all the time, and you don't really know where your traffic is coming from. So MongoDB Atlas, we really think is sort of the simplest way to run MongoDB. It's all about sort of making it really easy to manage the cluster from day 1 to day 10 to day 1,000. We think it's sort of the most robust way to run MongoDB. Not only do you have sort of all the best practices from all of sort of our experience running MongoDB, but you've got us to help. So when something goes wrong, instead of you getting a text message at 3 in the morning, if our service can't automatically fix it, we get a text message at 3 in the morning, and we'll take care of it, and we'll fix it. And we think it's incredibly well sort of elastically priced. So when you spin up a MongoDB cluster, you're paying by the hour. You can scale that up very easily, scale it down. You can try it out for 2 hours, and it costs like 15 cents. So it's all pretty easy to do. So when we were thinking about MongoDB on AWS, we wanted to make it incredibly sort of the obvious choice. So we're at an Amazon conference, so it only is fair to sort of give credit to Mr. Bezos. But with Atlas, we really wanted to be sort of crazy to not use Atlas if you're running MongoDB in AWS. So we want it to be such a, from a reliability standpoint, from a security standpoint, from an ease of use standpoint, and from a price standpoint, we want it to be sort of incredibly obvious that using Atlas on AWS is sort of the right thing to do. And we think we've built it, priced it, and designed it so it can be exactly that. So we'd like everyone here to sort of migrate to Atlas pretty soon, today if you want. There's a lot of ways to migrate to Atlas. You can use sort of MongoDump and MongoRestore. We've got a new tool coming out pretty soon called Mongo Mirror, which will let you sort of migrate a live cluster running anywhere else into Atlas, sort of in real time, which is pretty nice. And then in Q1, we'll actually be launching a service. And that'll be sort of a service inside of Atlas, so you can actually migrate your clusters from anywhere else into Atlas very seamlessly and very easily. So that's all pretty excited. If you go to Atlas and create a new cluster today, you can use this code GETATLAS, and you will get a free credit of $100, so you can just go and start spinning up clusters and try it out for free. And that's pretty nice. So again, Atlas has been out since June. The reception from, feedback from our users has been very positive, so we really expect it to be sort of a really great experience for everyone who wants to use it. There is sort of a very large roadmap of things we want to do inside of Atlas. So things like, maybe you don't want to only run in AWS, but you'd like to run in other clouds. Maybe you want to be able to have a cluster that is cross-cloud. All sorts of interesting things that we want to do, as well as integrating it with other MongoDB offerings. So lots of really exciting things, and I hope everyone is pretty excited about it. So now we have some time for questions.